What's up guys, welcome back to the channel. If you're working in a shop and you're pulling V6 jobs regularly, oil leaks, timing issues, misfires, but you do and fully understand the actual architecture of what's sitting on that engine stand, this video is for you. Today we're going full deep dive on the V6 engine from the technician's perspective, internal components, firing orders, common failure points, and a real diagnostic approach. Whether you're a seasoned tech or still building your skills, stick around. Let's get into it. The first thing you need to understand about V6 engines is that not all V6 South are the same, and bank angle is a big reason why. A 60 V6 is mechanically the most balanced configuration. The inherent first-order forces cancel each other out. However, some second-order imbalance remains. That's why certain engines use balanced shafts to smooth things out further. Firing order is something every technician working on V6 engines needs to have committed to memory, or at least be able to look up instantly. Misfire diagnosis, coil-on plug swap testing, injector sequencing, all of it ties back to firing order. Always verify firing order against the vehicle-specific service manual. Assuming the wrong firing order is one of the fastest ways to misdiagnose an ignition timing or misfire fault. Let's talk about the top end, specifically DOHC versus SOHC configurations, because how you approach a valve job or timing repair changes depending on what you're dealing with. On DOHC engines, cam phaser failures are extremely common. The phaser is oil pressure dependent. Low oil pressure means cam timing retards, and that shows up as rough idle in codes like P0010, P0011, or P0014. Don't just swap the phaser without addressing the oil system first. V6 engines use both timing chains and timing belts depending on manufacturer and generation. Diagnosing chain stretch, metallic rattle on cold start, first 2 to 3 seconds, then clears. Cam timing codes, P0016, P0017, P0018, P0019. In live data, check actual versus desired cam position. Any significant offset points to chain stretch or tensioner failure. Bank 1 and Bank 2 timing chain tensioners don't always wear at the same rate, but when you in there, replace the full timing kit. Don't leave one side marginal. When you're doing a bottom end inspection or rebuild on a V6, crankshaft measurements are non-negotiable. Use plastigauge to verify bearing clearances during assembly. And remember, if you're dealing with torque to yield TTY bolts, they must be replaced. Never reuse them. A solid understanding of the V6 oil system will save you from a lot of misdiagnosis, especially on VVT-equipped engines. Oil circuit flow. Oil pan gives oil pump, crank-driven, gives oil filter, gives main galley, gives main bearings, gives rod bearings, gives cam bearings, and VVT actuators gives drain back. Mechanical oil pressure testing. Always use a mechanical gauge. Never trust the dash gauge alone. The oil pressure sending unit on VQ35 engines is notorious for thread sealant breakdown, leading to false low pressure readings. Always confirm with a mechanical gauge before condemning the engine. The dual bank layout of a V6 adds a layer of complexity to the cooling system that you need to account for during diagnosis and repair. Common failure points. Intake manifold gasket leak, water pump bearing failure, plastic thermostat housing cracks. Coolant system pressure test. Hold at 1.0 to 1.2 bars 1417 psi for 10 minutes. Any drop indicates a leak, internal or external. Misfires are one of the top complaints you'll see on V6 engines. Here's the systematic approach. Step 1. Confirm codes. Step 2. Identify the cylinder. Step 3. Swap test the coil and injector. Step 4. Compression test. Step 5. Leak down test. For VVT, cam timing codes P0010, P0020, check OCB resistance and filter screen. Monitor live data for cam position offset and check oil viscosity. Using the wrong oil grade will slow phaser response and trigger these codes. For NOx sensor codes, don't replace the sensor first. Find the root cause: carbon buildup, low octane fuel, EGR malfunction, or a faulty coolant temp sensor. On most V6 engines, NOx sensors are located underneath the intake manifold. On a V6, if one head gasket has failed, address both. Critical steps. Follow the OEM head bolt torque sequence, replace TTY head bolts, check head surface flatness, and inspect the block deck surface. MLS gaskets require no sealant. For DOHCV 6-valve clearance checks, the engine must be cold. Always mic the shim before installing. Shim kits occasionally have mislabeled sizes. Alright guys, to wrap it up, here is what separates a technician who just replaces parts from one who actually understands the V6. No. The bank angle and firing order. For VVT diagnosis, check oil quality and OCV before condemning the phaser. For misfires, swap test systematically, then go mechanical. For timing chains, cold start behavior plus cam codes tell the story. For a head job, do both banks, replace TTY bolts, and follow a strict torque sequence. Drop a comment below. What is the most frustrating V6 fault you've ever run into in the shop? I'd love to know. Next video is going to be a full VQ 35DE rebuild series, if that's something you want to see. Hit subscribe and the bell so you don't miss it. Stay safe in the shop. Torque everything properly. See you next time.